All right. Okay. Today is the 28th of March, 2026. We're doing POTD, and I've promised myself that I'm not going to be dumb today. Oh, it's a hard one. Okay, I might be a little bit dumb. We'll see. Find the string with lowest common prefix. Is that what it is? Yep. No, longest, not lowest. I was dumb. Anyway, already failed. We define the LCP matrix of any zero indexed string word of n lowercase English letters as an n by n grid. Okay, so let me just say that again. So it's 2 by 2, it's a 2D grid, 2D matrix. I mean, 2D array. It's a matrix that is associated with a particular word of length n, all lowercase. So we make an n by n. LCP at ij is equal to the length of the longest common prefix between the substrings word at I to n minus 1 and j to n minus 1. Okay, so taking the ith character and taking the jth character of... Okay, generally I understand. So just to clarify, you have a word, so of length n. The idea is you have your matrix such that when you look up the ith, jth element, ij element, it's equal to basically take the word from I up to word at n minus 1. That's like your first substring. Then take the word at j up to word n minus 1. So that your two substrings, these two substrings, and then find the length of the common prefix, longest common prefix, right? And that will be the value at LCP ij. Given the n by n, oh, you're given the matrix and you want to figure out what the word, the smallest that the word could be. If no such string exists, then return the empty string. A is lexicography smaller than B of the same length. If the first position where A and B differ, string A has a length that appears early, yeah, alphabetic, like dictionary order, yeah. Okay, so first things first, what do we know? We're given the matrix. We're given the LCP matrix. I thought we were going to be given the word, yeah. Anyway, it's a square matrix, which is pretty cool. And basically, the num rows, which obviously is equal to the num cols, because it's a square, is equal to n, where n is in turn equal to the length of the word. So without too much effort, we can find the length of the word, right? Because the length, like word length, is equal to LCP, the length of LCP, right? Like, we know that off the bat. So we know how long the word should be. The thing is, we want to make sure we get the alphabetically smallest. Like, you know, if we had the choice between it starting with an A or a B, we wanted to start with an A. Like, that's what that's all about. Oof, this could be pretty tricky. I don't know. I don't want to fall for like the trap of like thinking it's hard because just because it says it's hard. Because sometimes, you know, that can screw you mentally if you kind of over fixate on the difficulty. But okay, so you got constraints that n is between 1 and 1,000. So in terms of my constraints, so this is my input. Constraints n is between 1 and 1,000. So, you know, 1,000 means I'm allowed to go up to O of n squared, right? Because that'll give me a million, kind of scale of a million. And LCP ij is naturally between 0 and n, which makes sense because for any particular substring, you know, which is of max, like the max length of the substring is going to be n because the length of the word is n. So the longest common prefix can be 0 if there is no common prefix at all, you know, if one starts with an A, one starts with a B, like, and then can be, if they're the exact same word somehow, like if it's like 0, 0, I guess. LCP 0, 0, you would expect to equal n because it's the same number, like it's the whole word twice, basically, that you're comparing. So that's quite fun. So yeah, so a few like observations, I guess, just based on that. Like I just said, the LCP of 0, 0, you would expect to be n, right? Because LCP of 0, 0, you'd expect to be n because what is LCP 0, 0 querying? It's saying take the entire first string, take the entire string as a substring, and then do that again, and then compare. What is the longest substring? Well, it's the exact same word, so the longest prefix is going to be the entire word, which is of length n. So that's one thing we can for sure say. If LCP of ij is equal to 0, that indicates that, that implies that the word at I is not the same as the word at j. I think that's going to be important. Else, we'll say R or something equal the LCP at ij, right? So this is saying that if we consider the position at I and take the R characters starting at I, and then take the position at j and take the R characters starting at j, they should look the same, basically. So I'm kind of assuming that in all my writing, I'm kind of assuming I is less than or equal to j. Like symmetrically, I think it would be a symmetric matrix, right? Like for I down here, j up here, versus I over here, j down here, it would be the same value, right? Like this value would match this value because it's the same word. Like you're looking at the same indices. I'll use a different color. If this is your I value, this is your I value, this is your j value, this is your j value. For this particular thing, where I is low, j is high, versus j is low, I is high, you'll get the same value out. Because it's the same indices, you just swap them around. So yeah, the other observation, LCP is symmetric. Is that important? Probably not, but we'll see. If LCP at ij is 0, then you know that these should be different letters. Else, else let R equal that longest common prefix, and basically LCP at I, LCP I plus 1 up to LCP R minus 1. That's the R characters starting at the not LCP, sorry. The word itself. Sorry. So the word itself at that ith character, I plus 1 character up to R minus 1, that gives us, that gives us R characters, is equal to the word at j plus 1, word at, I wrote this wrong, not R minus 1, I plus R minus 1, j plus R minus 1. Okay, so I've written this horribly, so let me do this again. So if the LCP ij is 0, then we know that the word at I is not equal to the word at j. Else, let R equal the value in the matrix, and basically we can claim that the word at I, word I plus 1, up to word at I plus R minus 1 is equivalent to word at j plus 1 up to word at j plus R minus 1. So this substring starting at the ith index is equal to this substring starting at the jth index, where the size of both is R, right? That's assuming if the length of the word is if the LCP value is greater than 0. Okay, so what I've managed to achieve thus far is basically a blueprint of like rules, right? Like, I don't need this eraser, what am I doing? A blueprint of rules. It's like a way of sort of figuring out what must be true based on the LCP values, based on the LCP matrix. Like, for any particular for any particular LCP value, any particular LCP matrix, sorry, these conditions should always be true, right? So let's like take an example now. I probably should have done this first, but I just wanted to really get an idea of what was happening. So we take this guy. I don't want you over there. Why would I want you over there? Come over here. There you go. All right, zoom in. So, example 4020 0301 20200101, right? And then so like this is my I side, this is my J side, and the indices are 0, 1, 2, and 3. 0, 1, 2, and 3. So what do we first observe? We know that the length of the word, so in blue, word length is equal to 4, right? The number of rows, number of columns tells us n, which in turn tells us the word length. So we know that. So we know the word should look like 1, 2, 3, 4. From there, we look at all the places. So like we said, word at LCP at 0, 0, we expect to equal the size of the word, because it's the same thing twice, which I think I said, yeah. So LCP 0, 0 is equal to n, so that makes sense. That's like, we knew that. From there, we know that at 0, 1, I'll put little indices here as well, 0, 1, 2, and 3. At index 0, at I0J1, right, this value, we get a value of 0, which tells us that index 0 versus index 1 should be different. Like, if this is, I was going to use letters. We'll just say, yeah, if this is like, I'll just say A1, then this has to be A2. They can't be the same, Like, I'm just going to use A1, A2, A3 like that, just to indicate, like, what has to be the same, what doesn't have to be the same. And then, so like that one's kind of handled. 2 over here tells us that 0 up to 2 not inclusive, and then 2 up to the n not inclusive. Sorry, I said that wrong. This 2 over here tells us that if we consider 0 and 1 as one substring, and then 0, 2, and 3, and then index 2 and 3 as the next substring, right? Because this is length 2, this is length 2. This 2 tells us that they match. So we get this idea that like this should also look like A1, A2. And then, is that enough? And then 3 and 0 don't look the same. So, which is confirmed, right? 3 and 0 don't look the same. And then 0 and 1 don't look the same. I only really, like I said, I only really care about things sort of here, right? Because it's a symmetric matrix. Is it symmetric? It looks pretty damn symmetric, yeah. Hang on, let me just slice this down the middle. Yeah, it is. It's got to be. Makes sense. Yeah. Okay. So I only really care about like the j values that are greater than or equal to I. Okay. So then, yeah, for I equals 1, we get a value of 3. Oh, this is interesting. Okay, so this is saying, right. The values along the diagonal are useless because it's saying take the first. Wait, hang on. Does this make sense? Yes, it does. Sorry. This is saying, take the this 3 is there because you're saying take 1 till the end, and then I is also 1 till the end. So you're looking at the same thing twice, so you get 3. Okay, so the diagonal, okay, so in general, actually, I can add that. In general, diagonal values are kind of useless because they're predictable, is all I mean. Like, that's going to go 4, 3, 2, 1. It's going to go n minus 1, n minus 2, down to 1 for the very last ij pair, where I equals j. So really, I actually only care where I is strictly less than j, because that's where the actual information is. Where I equals j is information, but it's redundant. We know what that value will be. So we care about that. Okay, so I don't care. So really, I only care about these values. I don't actually even care about the diagonal. So then from there, they should be all the same information. So 2 and 1 don't match. That's what this is saying. 3 and 2 don't match. And so we get this idea that A1, A2, A1, A2. Well, we can kind of set A1 to equal A. Remember that we want the word that would appear at the top of the dictionary. So A1 equals A, and then A2 would equal B, and then we substitute. We say, okay, instead of A1, we can write A, B, A, B, and I'm assuming that's right. Yes. Do I want to work through all the examples? I kind of do. It might be a bit slow, but I don't really know how to do this as a computer. As a human, it kind of makes sense. But what would my logic be? Like, do I just want to store, like, do I want to use this idea of a construct A1, A2? Could I just, instead of doing, can I literally just start writing by A? Can I just say A and then go B? Based on the rules given, basically, all the zeros I see, all the twos and the ones I see. Oh, this is one. Because, yeah, 1 and 3 should match. Yeah, okay. That makes sense. Is that redundant? Is the fact that there's a 1 here, is that redundant information? Because I kind of knew that when I saw the 2 here, right? I knew that 0, 2, 0 and 2 have the length of 2's prefix common thing. So I knew that this guy would match this guy without having to look at the 1, technically. So is there a way to remove, do I only have to look at like, I don't know. I'm a bit scared. Any ideas? Like, I think, yeah, doing it as a human makes sense. Doing it with a computer is like trying to keep track of all those rules, or like all those observations you're making as you go. Like, what's the cleanest way of doing that? Let me try another example just to like continue this idea. So we have this guy. All right, so we have 4, 3, 2, and 1, 3, 3, 2, and 1, 2, 2, 2, and 1, and 1, 1, 1, and 1. Interesting. So I is here, J is here, 0, 1, 2, and 3, 0, 1, 2, and 3. And so we only care about basically the values above the diagonal, I think. So like these values, basically. And then we know that the length of the word is 4, so 1, 2, 3, 4. We see that 0 and 1. Is it always fair to make it start with an A? Like, why would you not make it start with an A? In what world would it not make, like, surely, right? Like, this is an A, and then all the other rules follow from that, rather than, like, trying to keep this abstract, and then, like, figuring out, and then substituting this as an A anyway. Like, I'm pretty sure I can safely make this an A. Because the relationships or the rules are all, like, between letters. There's no rule that specifically is going to say, oh, the first letter can't be an A, right? Like, it's just going to say, well, if this is an A, then something else has to be a B. Like, it can't be an A. Something else can't be an A, or something else has to be an A. So I think I can safely make this an A. And then we'll say, well, look, looking at this, so, 0 and 1 share the same. Oh, okay. So this guy and this guy match. Is that what it's saying? Yes. 0 and 1 match for the same. There's no zeros, so everything looks like the. Oh, okay, yeah. There's no zeros in the matrix, which tells you that everything kind of matches. So it'll be like that, I think. I think I saw that already, right? Yeah. But what would be my systematic, programmatic approach to this? Like, such that I can do the same thing over and over, and I always get the correct answer. I wonder if it's like a transformative thing. So it's like, let's just say I don't know what these values are yet. So I call it B and C, just whatever. Like, I know that I need these 3 values to equal these 3 values. So like, I need these 3 to match these 3. But this doesn't make sense. And this doesn't make sense. Like, how a position can't be a B and an A at the same time. So to rectify that, it would need to be that. yeah, like this has to be an A, because looking at this window and looking at this window, we're saying, okay, the start of this window should match the start of this window. I'll do a different color. Hang on. Looking at these two windows, the start of the red window should match the start of the window, like the start of the green window. So this has to be an A. And then we iterate across. The middle of the green window and the middle of the red window should match. The middle of the end of the green window, which is that A, should match the end of the red window. So you get that. And then you confirm it. You say, look, looking at 0, 2, the first two elements and the last, like these two windows should look the same, that kind of thing. Can I immediately terminate when I finish filling in all the array, filling in the word? I don't know. Okay, let's take an example where it doesn't work, because this one said it was an empty string. So example, so 4, 3, 2, and 1, 3, 3, 2, and 1, 2, 2, 2, and 1, 1, 1, 1, 3. Interesting. So there's no zeros again, so that would suggest to me that it's all the same letter. Let's see, so 4 letters again. We only care about this information, everything else is redundant. So 0, 1 is non-zero, so they have to be equal to each other. 0 and 1 have to be equal to each other. 0 and the value is 3, which means, yeah, looking at the two windows, those windows should match. So just check, like, oh, it's the same letters everywhere, so you eventually figure out that it's A again. But then why would this go wrong? Because A2, did I copy the right thing? Yeah, I did. Yeah, okay, sorry. A2, like, sorry, starting at like I0J2 has a value of 2, which means these two should match, which it does. And then these two should match. 0 and 3 should match, which it does. Go down to the next value. I is 1. I is... Oh, but it's not symmetric, is it? Is that the issue? Hang on. Oh, no, it is. Sorry. Sorry. I is 1. And then I is 1. Okay, I feel like I would have returned A. LCP 3 cannot equal to 3. Oh, right. This condition didn't hold. Sorry. Okay. So yeah. So if LCP is not symmetric or diagonal does not go n minus 1, n minus 2, etc. down to 1, then return the empty string. I wonder if it's fair to say that, like, you'll only ever return the empty string if this happens. Like, is it possible to have these properties hold but still have problems? Like, probably, right? Like, imagine, like, again, we only care about the main information. So, imagine we have this symmetric stuff and everything. So we have like 0, 1, 2, 3, and then 1, 2, 3 with 0, and we only care about this information, right? 0, 1, 0, 2, 0, 3, 1, 2, 1, 3, 2, 3. Let's say these two don't match, and yet somehow let's say these two don't match. These two match twice, and then 1, 2 matches once or something. So imagine, we still have the n like 4, 3, 2, 1 property. We still have the symmetric property, but we have this kind of thing. I think this is contradictive because 1, 2, 1, 2, 3, 4. The fact that 0 and 1 don't look the same. Sorry, it's the fact that this value is 0 here tells us that they're different values. But then the fact that you have a window like this for 0, 2 tells you that these two should match. And then the fact that 1 and 2 have a thing of 1 tells you these two should match, which is a contradiction. So false. Sorry, contradiction, so return. Okay, so the cases where you return a empty string is either the blue condition, where the loop is not, the LCP is not symmetric, or the diagonal isn't, the main diagonal is not of the form n minus 1 down to 1, or you manage to figure out a contradiction. I'm concerned a little bit. I think, okay, let's say, I guess I do technically have a way of computing all this. Like, I have my answer string or whatever, and I make it of length. Maybe I'll do it as a list first, because you can't change strings very easily. I'll make it a list of characters, or a list of strings for Python. And so I'll have this idea of, whenever I check the window, whenever I check a window, I, compare the pair, make sure that they're either matching, or if they're not matching, I'll pull across the sort of next, I'll like make it so that it does match. I wonder if it's worth finding all the zeros first, so like where the non-equal characters lie, Like you have pairs where like, okay, wherever there's a 0, like I wonder if it's worth going in this order, like checking all the, I guess, adjacent relationships, like 0, 1, 1, 2, 2, 3, checking if those are equal. Yeah, is that helpful? That sounds kind of cool. Like, if this is 1, if 0 and 1 is bigger than 0, then you know that they have to match. And if 1 and 0, if 1 and 2 are equal, then they have to match. Otherwise, they don't match, and just make, ooh, and then use all the remaining. I think I like it. I don't know. I'm a bit scared, but I think it could make a lot of sense. So instead of going like in this order, which is what I was doing in the examples, I'm thinking like I'll go along this like diagonal order, and then maybe just, because I think by going along the diagonal order, I should be able to actually fill in the word completely. I think I have enough information to fill in the word that the matrix is suggesting. And then yeah, I'm a bit unsure, but I do think it maybe makes sense, because like if you're checking 0, 1, 1, 2, 2, 3, 3, 4, 4, like that, and you have this idea of if it's 0, then make, the jth character in the word one, like not the same as the previous character in I, make it one more, like one more being like B is one more than A, C is one more than B, like that. Like make it the next character available. And then for all the remaining values, I think your concern is, well, I'm allowed O(n) squared, so you might be allowed to just naively check the windows without having to do anything more efficient, but I think the speed will come from doing that window checking in a faster way. But if we start with this, I think it does work. So let's do that. Word length is equal to that, and then answer word is equal to an array of like, we'll say A for in range, oops. Answer word is, yeah, just to make it the right size. And then answer, the very first letter we want to be A anyway, which is good. And then, okay, I'll def check symmetric given LCP. Return false. And then def check the diagonal self LCP. Return false. Okay, so we'll check the blue conditions first. So if LCP is not symmetric, so I learned this trick in one of the problems we did recently, where it's like if you transpose equals, if you unpack a 2D thing, right, zip it and then convert it into a list, that gets you the transpose of a 2D list in Python, because you're unwrap, like I wrote a full-on like slab of comment on this, but basically unwrapping means like for the like a small case, if you have like 1, 2, and then 3, 4, and then that's in a 2D, if that's your original, unwrapping basically like the unpacking operator, that thing, doing this basically just does this, and so that becomes the input of the zip, which basically takes the 0th index elements in the rows and puts them together, and then for the first index puts them together, right? And then by casting into a list, you get the list of this. So you just wrap this in list, which is the transpose, because like you took, right, the zipping thing basically took all the column, all the elements in the same column and put them in a row, and did that again for 2, 4. Like this was very cool. Anyway, return the LCP equaling the transpose. So if they're the same, which can be done, then yeah. Now this might be not as efficient as if I literally just go for like if n is equal to the length of LCP, then for I in range n, for j in range n, if LCP at ij is not the same as LCP of ji, this can say I plus 1, can't it? Yes, it can. Or can it? Might be safe. Wait, let me think about this. ij, I'm going down the rows and down across the columns, but I only really want to go down as I go down the rows, I only really care about, yeah, I can say I plus j, I plus 1 up to n, then return false, otherwise return true. I don't know which one's faster, because I feel like the zipping and stuff might be more annoying than, I like the trick anyway, so I'll just keep it. And then n equals the length of LECP, length of LCP, for I in range n, if LCP at II is not equal to n minus I, then return false. So this is me checking, for the 0, 0 element, it should be n. For the 1, 1 element, it should be n minus 1. For the 2, 2 element, it should be n minus 2. Down to LCP of n minus 1 element, which should be n minus 1, which gives you 1. It's checking that condition well. And then if we get through that whole thing and the whole thing happens, then we are happy. Now, we can quickly say if self.check symmetric given the LCP, if that's false, or self.check the diagonal of the LCP is false. Eyes is false. Then return the empty string. So this is me basically handling this case. So really, if I was to run this now, third test case should work because it wasn't the diagonal thing failed. Very good, right? Otherwise, do this. Now I'm going to do my thing of for I in range, all of the rows, right? I in range n. I'll just say n. And then for j in range I plus 1 up to n, because I don't care about the diagonal information either. Wait, no, but I don't want to do it like that. I actually only want to do this. The column, so this is my row. My column is, I said I want to get the I plus 1th value. I plus 1. In fact, I don't even want the last row because that's not going to have any information. So I minus 1. Yes. Okay, so the column is this one. If the LCP at, maybe I will say ij just because I've been using, if the LCP at this I value and this j value is equal to 0, okay, then the answer at the j index, you should take the answer at the I index and add 1 to it. So to do this, you say odd to get the ASCII integer value, and then to make it back into a character, I think you say CHR. Does CHR convert int back into character in Python? Oh, okay. So odd makes it go from character to ASCII integer value, and then I add 1, and then is there a risk of me running out of letters? Yeah, there is, isn't there? Wait, yeah, this doesn't work. Wait. What if I'm saying I have to increase every time, but what if I go back down? Oh, okay, I see where the difficulty lies. Damn, I thought I had it. Wait. So for example, in the AB case, I would say A, B, C, yeah. Because there's no relationship between these adjacent characters are all not equal to each other. You know? So okay. So maybe I do just want to go across. Is it better? I figure out whether or not the yeah, maybe it is better just to go across. Because it's good to get the relationship. Because then you get the relationships of the... Oh my goodness. Okay, hang on. If you get a value of 0... Okay, hang on. Let's see this again. So for I in range n minus 1. So I don't care about the last row anyway. For j in range, I guess I plus 1? Yeah. Up to n? Because I do care about j going to the end. Maybe I should just make it all none for the, instead of saying a, because I feel like I'd rather it not have a legitimate value. And then say answer word at index 0 is equal to a. Can the word be... No, okay, so there's at least one character, which is good. Alright, so... So we see a 0 here. That indicates they shouldn't be the same. Then we see a 2 here. which indicates that the character at index 1 versus the character at index 3 should be equal. So we should set them to be equal. And 3, 0 tells us that, yeah. Do I want to? I'm worried about, because like in this case it works out, I think, where like 0 and then a 2 tells you that index 1 and index 3 should match, and then the 0 here tells you that index 0 and index 3 shouldn't match, which would work out anyway. And then like after that you actually have the whole string, and everything else just follows, like everything else reflects it correctly. But my concern is, like, what if you have 0, 1, sorry, 0, these should be green indices. 0, 1, 2, 3, 0, 1, 2, and 3. I only care about these values. So if I have a y, if I have a 0, another 0, another 0, can I have like a 1 here? You know, like, I don't know, I just feel like, so like this is an A always, and then this is not the same as A, so this has to be a B, and this is not the same as A. But like this could either be a C maybe, or it could be a B, right? Like we don't actually know yet. So it's not easy to just make a decision straight away, because maybe it should be a completely different value to these two, or it should be the same. I'd have to look at 1, 2. And since the value is 1, then that indicates that it should be a B for that to work out. And then same thing, like 3 is also 0, but should this be a B or should this be a C? Maybe it's better just not to set it to anything then. And then like when you're done, all the nuns that are left, if you have any nuns left when you're finished all this, what do they indicate? Indicate that you need to use letters that yeah, like, is it good to use tuples? Like, is it good to use possibilities rather than like sets? This can only be the set of A. This can only be the set of B because it's either the set of A, but it can't be because of the 0. And then this one, it could either be a B or a C, because all we know at this point is that it can't match A. We don't know anything else about the B or the C. Yeah, what if like I make every character the set of all 26 letters? And then as we realize that it can't be a particular possibility, or it can only be one possibility, we like pop off the set. We push, like we take things out of the set, and like if we get a definitive, oh, it should be this, then, oh, is that weird? I kind of like it, but it's kind of strange. I mean, each set is a max size of 26 because of the constraint, so which is nice. Okay. Letters is equal to C for C in range order A up to order Z plus 1. I need to do the CHR thing to get the character back. So we get all the letters, and then we say this is the set of all letters, and the answer word at the start is just the single character. There's only one character I want there. Is this dumb? Maybe. But what can we do? So what I'm thinking is like, if if LCP at ij is equal to 0, that tells you that answer word at j shouldn't have the letter at I. I don't think this is going to work. This feels a bit silly. What if they point to particular sets? Like, there's the set of A, and then we create, like, when we realize that B has to be can't be an A, we know it can be a B, so we have a set like that. And then at some point we realize that the third, index 2 has to not be the same as index 0 because the thing is 0. So we know it has to either be a B or a C. And then because of some LCP value, we know that this guy and this guy should match or something. Or, wait. Sorry, I said that wrong. Oh, I'm getting a bit out of it now. I really want to figure this out because I really think I could, but I just don't know what exactly to do. For I in range n-1, for j in range I plus 1 up to n, if LCP ij is equal to 0, answer word at j is equal to LCP at ij, then the answer word at j should equal the answer word at I. I think I've overcomplicated it. I'm just going to go back to my original idea. I'll just take this. So if this is the case, and maybe I will make this none though, because I think it is good to say like, hey, I haven't actually touched this letter at all yet. Answer word at 0 equals A. So if this is the case, and answer word at J is none, like we haven't touched it yet, then we can very safely just like do this. I think if LCP ij is greater than 0 and answer at word I is not the same as answer at word J. So what I'm trying to get at is, like, you've somehow edited this letter already. You've somehow edited the answer J word already. and by some constraint, you like there's some contradiction. Like this is saying that they should be equal, but by some other rule, you made them so they're not equal. So then return that, I guess. L if LCP ij is equal to 0, I think I need to do more. Maybe I should just say while this is greater than 0, R is equal to LCP ij while R is greater than 0. And we'll say L is equal to ij, R is, oh wait, okay. L is equal to I, R is equal to J, and instead of R, we'll say the window, or the longest common prefix length, while the prefix length, I don't know, I put an F there, while it's greater than 0, if the answer word at the left at the right is none, then simply set answer word at R equals answer word at left. I think I will be incrementing this and incrementing this as well as I go. If answer word at R is not equal to answer word at L, then I think we found a prediction, so return this one. Else they are equal, in which case that's what we wanted anyway, so that's fine. Now, do I know that answer L will be not none at that point? I think so, because initially 0 is not none, and then you would have set... Okay, I have to figure out this case. If... I don't think I need this actually, because that's kind of handled here. LCP ij is this. We handle the entire window. If it's equal to 0, if the word, answer word, at j is none, then what do I do? Elif answer word at I equals answer word at j, then we have problems. We should return this because we found a contradiction. We're saying, you know, according to this, they shouldn't be the same, but apparently some other rule told us that it should be the same. Answer word j is none. I don't know if I should set it to like just the next character that I should like available, like B, or...
I feel this to go to shop. You want to go yourself?
Yeah, I'll go.
Okay. Because I'm reading the...
Yeah, don't worry. I'll, yeah. It's just weekly shopping, right?
Huh?
It's for weekly shopping. It's not for tonight, right?
No. You buy for tonight one.
I know, but I can also do weekly, like the normal.
I wanted to go for weekly, but...
I'll go.
I'll go tomorrow morning.
I have the car anyway. Like Aka's car.
For tonight one?
Yeah. Like, as in I can buy my stuff and then I can also buy the weekly stuff.
Including your milk, okay?
I'll get like the main stuff, yeah.
Other weekly I will do tomorrow.
Okay. 340. 3:40. Oh, I can use the time. Okay. Anyway, if answer word J... I need to close the door again. If answer word J is none, then do I set it to what? What do I know at this point? IJ is equal to 0, which means whatever is at I, it can't be at J. If I haven't set J yet, that indicates that there was not any window, there's no like, what am I saying? If I haven't set J yet, because answer word at J is none, then I, oh man. If I haven't set J yet, then that indicates that I haven't touched it yet. Oh, yeah, actually, why would I not have seen J yet? I would not have seen J yet because like after the very first row, after I equals 0, this is the wrong thing. After I equals 0, I would have hit every single J value, right? 1, 2, 3. So in all subsequent I values, J would be set to something, surely. Well, depends on what I do in the 0 case, but I think this is my risk. This is like this particular case. So where, okay, I make this A, and then, okay, fine, let's just say I figure out to make this B for some reason, and then A1. See here, but see in this case, because of the 2, I knew to set this to be B as well. Okay. Because of the 2 here, I knew to set this to B already, like assuming this while loop works. I know to set this to B because the L value would be 1 and the R value would be 3. Because L started here, R started here, then I moved it down, right? I should be able to know that this is a B, and then when I check this condition afterwards, where these shouldn't match, they won't match, which is fine, which is good. Now, the 2 means that this one got touched. So if this didn't happen, maybe it is safe to just make it the next character I can make, because in my mind it's like, look, if this is 0 or 1, let's say, what does that tell me? That actually already tells me that 0 and 2 match, but 1 and 3 don't match, right? Because if they did match, then this would be a 2, not a 1. If this was a 1, then that tells me already that these guys shouldn't match, so I should just take on the next value. So if this one never got touched, I think it is safe just to take the next available character, whatever that is. So I think it makes sense to have like a... maybe I'll just do it separately, like... sorry. It's just nice to have it as a property. Self dot last used char will be A at the very start. Like after this point, right? That last used char is A. Next char is equal to chr ord of the last used char plus 1, and then bring it back into a character. Next char is this one. Answer word at J is equal to this next char, and then self dot last used char is equal to next char. That's what next rung above. And then if I can get into that whole thing without any contradictions, then return the, what is it? This dot join, I think. Ants word. Oh my goodness, I clicked the wrong button. Oh. Okay. Print I equals I, J equals J, found inequality when there shouldn't be. That's a dodgy sentence. I should do this before the return statement. That would make sense. And then found inequality when there should be equality. When there should be inequality. Let me see. All the places that I return. Okay. The other thing I can do is maybe I'll do this separately so I can really make sure. Print not symmetric. Print not diagonally correct. And then what I'll do is I'll just print the current answer word. It's just so I can see the progress. Not symmetric. My symmetric thing failed. That's a real shame. I tried to use my my cool trick, but it didn't work. I think this should work. Let me double check. So for each row, for each column starting not at the diagonal but one past the diagonal up to the end, if ij is not the same as ji, then return false. Oh no. Did I change it to n? Yeah, I did. My bad. Okay, although that means it passed through that, which is good. Oof! It does pass cases, but these are very small cases. My concern is that I'm missing something where it's like, if there's a bigger case, maybe, like, what do I think could happen? Like, let me try and be clever and actually prove this properly, right? To whatever degree. So I think I back this, right? Like, checking for the symmetric stuff, checking for the diagonal stuff. If either of those things fail, then there's no way this can be a valid LCP, right? We saw that in our observation section. Fine. Answer word. So yeah, I'm saying none because I want to indicate if I haven't ever edited this word before. That is, I only ever edit a letter if I am 100% certain that it should be a particular letter, you know? Like, I only edit a position in answer word if I'm 100% certain that the letter should be this kind of thing, right? Otherwise, none. I got no idea. And then I know that the very first letter should be A. I don't know if I wrote that down, but I think we talked about that, so that's fine. Yeah, I talked about it. Okay, and then yeah, we're iterating. I thought I should be clever at first, but it didn't work, so we're just going to iterate across like this. From here to here, then from here to here, then from here to here. We're ignoring the diagonal values because they're redundant, and we're ignoring everything beneath because it's symmetric and therefore redundant. So from here to here, then here to here, then here to here. Okay. So for each row up to the very last one, not inclusive, and then for each column past I plus 1 up to the very last column, up to n, not inclusive, I'm printing the thing. If this is greater than 0, then we know that there's a window that needs to be formed. Pre-len, the prefix length, maybe I do want to say prefix. I feel like that's not a very good name otherwise. The prefix length starts at that. L starts at where I was, and R, right, starts where J was. While the prefix length is greater than 0, if answer word at R is none, that is, we haven't touched it before, then answer word at R is equal to answer word at L. Because, yeah, like, that's what the window is saying. LR should match L. Else if the R does not match L, that is, we've touched R before, and it wasn't, and, like, we were quite confident in what it was, and now it's not matching L when it should, then we should return the empty string. Increase, increase, decrease. Fine. Elif, LCP, like there's a lot of, this is kind of weird, but it's fine. If the LCP is equal to 0, then answer word J is none. Next char is whatever the next char should be. Answer word should become that next char, and self word is next char. So, okay. I got to split this into two cases. One is where the LCP at ij is greater than 0. Notice that within this particular loop, the invariant, I think there is an invariant that says answer word at I will definitely be not none. Like it will be a number, because the reason why I think you can say that confidently is because either I is 0, in which case that's definitely not none, or the value of I used to be a value of j, right? Like if I is 2 at this point, like if at a particular point in time I is 2, at some point when I was 0 or 1, j was 2. So we've whatever I value we are using, we have seen it, it's either 0 or we've seen it as a j value. Now when we see something as a j value, we definitely either edit or return. Like LCP at ij is greater than 0, answer word at r, right? Like we either edit that j value in the very first instance of this prefix length loop, we definitely edit the j value, or if we're in the second case, we definitely edit it here, or we terminate, right? Or yeah, in the case where it hasn't been touched yet, we edit it, all right? And in the case where it hasn't been edited, we edit it. Like, so every single I value that used to be a j value will have something in it, I think. So we know that invariant says that answer word at I will not be none at this point. So that's something that's interesting. From there, we know that the value of answer word at I follows all the, I'll call it 0 rules, where 0 rules refers to like, oh, this character I shouldn't match any of these other previous characters because there was a 0 in the matrix. So it follows all the 0 rules because we made sure it did when we did this. And like if it didn't follow a 0 rule up to this point, then this should have returned, right? And it follows all the greater than 0 rules. So all of the rules where like, the matrix was greater than 0, we do our little window check, right? We know that the character matches correctly and everything. Otherwise, if it didn't, then I think this would have returned. So the value of, like, the rules are all the rules have been followed at this point. So we check LCP ij, and if it's greater than 0, then we have to try this window thing again. Oh, I don't know. I don't know if this proof is gonna make any sense. Prefix length LCP ij. While the prefix length is greater than 0, if answer word r is none, then answer word at r is equal to the answer word at l. If the answer word at r is not the same, then we've got a problem, because answer word at r was set to something, and the fact that it's set to something means it's following all the rules so far, but the introduction of this rule ij means it's contradicted. There's some contradiction in the rules. I think I'm worried about the cases where... What test case am I worried about? I'm worried about a test case where it fails because of some kind of contradiction. I'm worried that it won't see a contradiction, or it will like oversee, like it will like hallucinate a contradiction. Like it will think there's a contradiction when there isn't one, Like let's say it's like A, B, B, C, A, B, A, or something. I don't know. So 0, 1, 2, 3, 4, 5. So 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 5, 6. So this should go 6, 5, 4, 3, 2, 1 by the diagonal condition. And then this should be like 0. So 0 between these two, and 0 between these two. 0, 1, and 1. This should be 1. This should be 1, and then zeros everywhere. Maybe this is not a good test case actually. 0, 0, 0 because 0, 0, 0, and then 0, 0, and 1. Maybe I should just put like a thing over here. So 0 versus 0, 1, 2, 3, 4. 0 versus 0, 1, 2, 3, 4 should say 2. And this should say 0. And this should say 0 over here. So 1, and this should say 1 over here. This should say 1 at the end over here. I don't know. I don't know. It kind of seems like it could be right, but I just don't have any kind of proper proof that it works. If the answer at word R is none, are there any like nice test cases that people gave? Nice. Oh, thank you, mate. Appreciate you. Oh, I think actually, there is a sort of thing I could do, actually. There's another condition. I'll just say m is equal to the length of LCP 0. I just realized, like, I assumed it would be square, but they don't actually say that, do they? How do I go back to the... All right. Oh, no, they do say that. Okay, I don't have to check this. Never mind. It will be square. It will be square. I thought maybe they might give like a non-square matrix. Were these the test cases? My bad. Hang on. So these are the test cases I had wrong. And then these were the cases that were useful. All right. Let us see if my thing handles it at all. What? Oh my god. Answord. How did I even do that? I don't even remember touching that. Oh. Interesting. Two, 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 one. What happened there? 2, 2, 2, 1. It is symmetric. And then we only really care about this guy. So it's characters 2 characters long. The word is a 2-character word. And then we say, what is it saying? It's saying that you should match with you, which doesn't make sense. So there's a third condition. There's another reason it could fail, which is if the number doesn't make sense. So if I say, if the R value is literally off the string, then can I just simply return this? Because it's like, you didn't even... If the R value is off the string, then that doesn't make sense. Oh! Oh. Ooh. I did ask, like, can I run out of letters? Like, what happens if I run out of letters? And I guess that's what happens. I don't like how all these are fail cases. I would like a few, like, success cases. All right, so I'll just say, if the next used character, if order of the next char is strictly greater than order of z, then return the empty string. Wait, what am I doing? Sorry, this is... I've been doing some Java, sorry. Alright, do I back it? I don't know. I really don't know. Screw it, whatever. If there's a logic error issue, the easiest way to find it is by just shoving it through test cases. Is it slow? Ah. Oh. Oh, wow, it wasn't even a valiant effort, it just... okay, let me get rid of that. Well, I had no proof, and there we go. So let's see. So once again, it should have been no output, but I got letters instead. So let's see what happens. So copy this first. 4 1 1 1 1 3 1. Why was it so slow? Was that just like the servers being bad? Because like it doesn't seem like the input got particularly big yet. 0 1 2 3 0 1 2 3. I only really care about, well, first we'll check the diagonal condition, that's fine. Check the yep, symmetric condition is fine, so we only really care about these values. Oh, I know what I've missed. So I have the checks like, oh, if you try to, like, if you have a big number and that big number, if you have a big window size and somewhere there's a mismatch in that window, then you've got a problem, right? Like, I have that logic, but I don't have, what if the window is too small? What if the window is too small? Because, for example, my logic basically dictates that, 1, 2, 3, 4. This one should be an A, as always. And then basically, 1 and 0 and 1 should match. 0 and 2 should match. And 0 and 3 should match, right? But since if this is the string that I end up getting, then really the value at 0 versus 1 shouldn't be 1, it should be 3. There's a size 3 thing here. It shouldn't be 1. So it's like I followed the rules in terms of like I didn't have any mismatches, but the values in here, the ones do not reflect the longest common prefix. I wonder if it's worth to almost, for example, in order to handle this kind of thing, is it worth to be like, look, since this is a 1, I know that this guy should be A, right? Because this guy's an A. But then this guy cannot be an A. He has to be like a B or something. You know what I mean? Like, because it's not an A, so it has to be a B. Is that kind of the idea? I have A, and then I just like chuck in a B because I know it can't be an A. I'm not sure. It kind of makes sense, but if r plus 1, like if the next guy over, so like this would be my L value, this would be my R value, prefix size is 1, and so after that r plus 1 would point to here. If r plus 1 is a valid index, then we know that the answer word at L plus 1 cannot equal answer word at R plus 1. Like, if that makes sense. Like, L plus 1 refers to this guy. R plus 1 refers to this guy. L plus 1 refers to you. R plus 1 refers to you. If they match, then the window size would have been bigger. Whoops, that's not the right thing. If they matched, oh no, it is. If they matched, then this would have said 2. not 1. You know what I mean? If they matched, then this wouldn't have said 1, it would have said 2. So they can't match. How do I indicate that? What letter should it be? Should it be just the next character up? Should it be... Should it be the next character? I'm a bit nervous to make it the next character up because I don't actually know it should be the next character up, right? Like what if, for example, I have A, B, C for like as my current, and then I have like A, B, and then like none, and then none, right? This is my answer word. So like let's say this is like 0, 1, 2, and this is like 5, 6, 7, right? So you know, at this point, the LPS array at 0, 5, let's say it equals to 2, right? I know at that point that like, okay, yeah, this equals that, which makes sense. That equals that. And because it's 2 and not 3, I know C cannot be in position 7. I cannot have a C. I know that because like, and if I do get a C, then that's really bad at any point, right? So then I have to somehow write that down, be like, okay, look, position 7, no C. But I don't actually know that this should be like a D. Maybe it makes sense for this to be an A. You know, maybe 0, 7, like LPS at 0, 7, maybe that equals 1. In which case this should be an A. Or maybe it should be a B. Or maybe it should be a D. So I don't think we can actually change this thing. What I just had an idea was, what if I have a set of like hang on. Where's my list comprehension? Here it is. No, wait, this is not what I wanted. What did I want? I wanted this one. Can't have, which is basically just a list of empty sets for in range n. Okay, hear me out. Whenever I get something like this, I say can't have at the r plus 1 add whatever's at L plus 1. And I'm pretty sure I know that that should be set to something. Like, I'm pretty confident that L plus 1 will be a letter because L, like R was like R, which comes after L, would have been set to something. And so I'm pretty sure everything before R would have already been set at that point, kind of thing. I'm pretty sure this is safe. Can't have, add the word. And then from there, when we're about to do this, and answer word at L, not in, hang on. If answer word at L is in can't have at R, is in this set, then I think we have a contradiction. It's like the other contradiction that exists. if answer word L is in can't have it R, then we can't do this. L if we haven't touched it, then we know it's allowed, and we know that it's allowed to be there, and we're going to set it to that, to say that this is the letter we're going to make answer word R. L if answer word R is not equal to answer word L, that is, we have set R to something before, but it's not equal to what it should be equal to in this by this rule. And then yeah, can't have at R plus 1. That set, you should add whatever this letter is. Did it work? No. I was worried about that. I thought maybe none would be added for some reason. Does that mean that L plus 1... Alright, let me print both. Let me print answer word. And I'll also just put a bit of white space just to... A none none none. See, okay, this is what I mean. When I set this to A, because, you know, there was a value of 1 in the matrix, I know that this shouldn't be an A. This should not be an A, because if it was an A, if this could be an A, then the value would have been 2, not 1. And so this would have matched to this, and this would have matched to this. So my R value, my L value was this, my R value was this, my R plus 1 value is here, my L plus 1 value is here. So it should, this set should eventually have an A in it. I don't know why it didn't. Going to add letter none. What do you mean? Going to add letter Oh, because sorry, it's not plus 1. It's not plus 1. There's an increment at the end. There's one more increment. For some reason, I thought I terminated without incrementing again, so I had to do it plus 1. I don't have to do plus 1. It gets incremented for me. Oh, man. Is it right? Is it right? I don't know. It's just like, what types of contradictions are left? What else could there be? I don't know. Is it really slow? I forgot it was slow. Why is it slow? I just go through all the elements, no? I go through all the elements that are non-redundant. Damn it, now I'm too cautious. Now I went the other way. Now I'm outputting this when I should have. Oh my god. This is gonna be like 3 hours long. 1, 2, 3. Oh my goodness. 1, 2, 3, 4. 1, 2, 0. 0, 7, 0, 1, 1. 0, 0, 1. 0, 0, 6. 0, 0. Alright, I'll do it for like another 15-20 minutes, and if it's not coming, then I'll concede it, because this is insane. This is a bit more unwieldy than I hoped. There's 4 zeros, right? 1, 2, 3, 4. I am sort of doing like first aid to my code as opposed to like actually logically figuring out. But I just keep thinking that I've got something logical going. I don't know. I thought I'd handled all the different like conditions pretty well, and I had done all the right observations. And I thought I just was missing one thing. It turns out I was missing a whole lot more than one thing. All right, so okay, I'm gonna assume that the fact that the code got to here means it's symmetric is fine and all of that. 4, 3, 2, 1. So these are the values I care about. Let me zoom out a little bit. 0, 1, 2, 3, 4, 5, 6, 7. 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we know that this is an A. We know that this cannot be an A, so we'll make it a B. We oh right. I think this is actually kind of dumb. I think wait. This is the issue I had. As in A, B, this is index 1, this is index 2, which means it's not an A. So all I know is that this isn't an A. I don't know if this should be a C or a B. Do I? Zero, 1, 2. So my understanding is I think my code would immediately make the C. Because it would have said, hey look, LCP ij is 0, answer word is none, then just make it equal to the next character. But that's not fair. You can't do that. Because how do you know this should be a C and not a B? There's no information to tell you that yet. And in fact, okay, in this case, I get lucky. It should be a C. But if I keep going, 0, 0, 0. So index 3, this is index 2. Index 3 is another 0. So I know it shouldn't be an A, but maybe it's a D. And I'm going to assume, yeah, so my thing said D, index 1. Yeah, so my thing would have thought, oh, it needs to be the character D, but actually it could be a B. I knew that. I actually forgot that that was an issue I had. I was like thinking, I swear I was like, oh, how do I know? And then I thought like the equals 0 condition is a problem. And then I just completely forgot. And like, oh, this is super logical. Okay, so, but the sets is helpful because all I know from this, all I can really say, I can't do this. All I can really say is that, hang on. All I really know is that my can't have at index j add answer word at I. That's all I know. Now, I'm a little bit concerned because you know what I could try? What I could try is something like maybe I have another set that's like letters used so far or something equals set. And then basically if the letters used so far dot difference with can't have at j, like I'll get, so allowed letters equals that. If the length of allowed letters is equal to 0, then I maybe then it's safe to do all this. Like, next char is equal to, the last used char, and then if it's, too big, then do that. Otherwise, answer word j next char. Last used char is that. Letters. It's got a bracket. Letters used so far. Dot add the next char. And then yeah. However, if it's at least one, then potentially, the character could be that character that you're allowed to have, or it might be some other character. Now, is it potentially the case that we still have some nuns in the array now? So for C in answer word, the can't have sets tell you exactly what you cannot have in the array, and the use so far tells you what letters you have at the moment. And you shouldn't need any more letters. Once you get out of this, you shouldn't need any more letters, I think, because, like, should I need... Because basically, at this point, if you're out of here and the none, and the thing is none, that means that the length of your allowed letters was greater than 0. So you never set none, You never set the thing to something other than none. For C in answer word, if C is none, then smallest letter is equal to the minimum of letters used so far difference with can't have... I need to enumerate, I think. Can't have I. And then answer word at I is equal to that smallest letter. Let me just print answer word before and after. I'll also print letters used so far, and I'll also print can't have sets. Damn it. I hate when it works now, because I'm like trying to... now I have to figure out if it's actually correct or not. I haven't done a very good job so far. Why is there so much white space? Oh, it's because I do an empty print, do I? Yeah, I commented everything except that. That's why I was like, why is there so many gaps? Going to add none to set 6. I'm nervous about the fact that it adds none. That wasn't really my intention. Going to add L plus 1 to set 6. How many letters are there? 1, 2, 3, 4, 5, 6. Like, there's 8 letters, right? So set 6 isn't even like the very last one. It's like literally this one. How come it didn't do any of this printing? Oh wait, it did. Let me do it again. Hang on. So you print the answer word, which is already not none, but fine. Then letters used so far as C and B. Okay, you also used an A, but okay. Letters used so far should have an A in it. I mean, the fact that it passed while having that mistake in there means like I don't know. How come it says going to add letter none to set 6, which is can't have? I guess adding none isn't that problematic, unless it's doing like, unless it means something really that I'm not realizing. If r plus 1 is greater than n, then we know that it can't have that letter in r plus l plus 1. I guess we just didn't know what L was, but I really thought we would know what L plus 1 was by now. Because, but I guess no, you know what? Because, oh no, I mean, do I want to print the answer word and see how it progresses? Whoa. Wait, I did not think it would do that. Why did it go like all the way to the back? What are these numbers? Yeah, because that's why. That's why you can add none sometimes, because my condition doesn't hold anymore. I thought that, to get to R, all of the previous letters would have been filled in, but that's not true anymore because I realized the information is a bit more nuanced than what I thought. So the 1 means that I know 0, 1, 2, 3, 4, 5. I know that this should be an A, but I don't know what these should be. Not yet. And then eventually A, because this is a 2, so I know it's AB. Wait, 0, 1, 6. Yeah, so I know it's AB at the end because it's AB at the start. Whoa. But see, like, if this said 3, right, then I only know A and B, and then all of a sudden there's a 3 in there. Maybe I can do that as a case. Hang on. What would happen if I... Whoops. Took this thing, and then I took the... So it's the first row, 1, 2, 3, 4, 5, and the 6th element. It's the 2. And then I would have to go... What's the corresponding thing? It would be over... So 0th row means 0th column. And then over here. So it's the 5th row, first 0th column. So the 5th index, 0, 1, 2, 3, 4, 5. And then... Wait, what? Sorry, it was the 0th column of that. 0, 1, 2, 3, 4, 5, and then change that to a 3, right? So that should make it symmetric, so that condition shouldn't break. Oh, okay, that's a bit not what I was hoping for. I wanted to see like somehow it would, it would know that this is an A and then this is a B, but wouldn't know what to make this. And then like this would be A and this would be B, but we wouldn't know what to make this. Although the information carries across, doesn't it? See, I think I missed something. I think that if... Hang on. If the answer R is none, and answer at word L is not none, then you can say that this is. Otherwise, L if answer word is none, and answer word at L is also none, then rather than being like, oh, just assign L to R because that doesn't do anything, I think I should carry across, like, can't have at R, I should make it equal to can't have at R, like, union with can't have at L. Like, all the information that I know about L can be applied to R because they're the same letter according to this. And maybe I can do it the other way around. Can't have at L should be can't have at L union with can't have at. I don't know why I swapped that. That's commutative. I don't know why I did that. But anyway, that could be a thing, you know, like because the condition that L is definitely set isn't true anymore. I'm just working with all these different sets. It might make sense to do that. Oh, wow, my acceptance rate is gonna fall. All right, these cases are getting too big to draw them by hand, so I'm generally gonna have to either figure it out or just allow it. 14 is, yeah, 14 is a bit much for me. I found I equals 5, j equals 7. I found an inequality when there should be equality. So when I chose to make it not equal, when I chose to make j not equal to I equals 5, then chances are I had the option to not do that. Oh man, can't have j add answer word I. Ah, okay, so I think I see what's happened though. The 5 never got... Wait, going to add letter A index 5 to letter 10, to set 10. But this is none. Why did it say letter A at index 5? Ah, this should say L. Sorry. Interesting. Okay, so found inequality when there should be equality. Found inequality when there should be equality. So I need one more case. Elif answer word at L is none, and answer word at R is none. It is not none, sorry, is not none, because that can happen. Then basically we don't know what L... Oh wait, no, we do know what L should be. Sorry. We do know what L should be, don't we? 1, 2, 3, 4, 5, 6. Yeah. Make answer word at L equal answer word at R. So we have all the none cases. Both are none. R is none, or L is none. And then we have, they're both set to something. Then... Okay, so I've actually exhausted every case. So that should be a bit more accurate now. I've exhausted every case of like either R is none and L is not none, in which case, you know, they should be equal. L is none, R is not none, in which case they should be equal. They're both none, in which case all I know is that whatever information I have about what they shouldn't be, they should share that information, but I don't actually know what they should be. And then, yeah. And then otherwise, if it's 0, then all I know is, look, should I check as well? Should I do the same thing if they're both none, if one is none, if the other is none, if they're both not none? If answer word at I is not none, and answer word at j is none, then yeah, do all this. Elif answer word at I is none, and answer word at j is not none. So actually the character after it is like the one that is set and the one before it isn't. We know that they shouldn't be equal to each other, so it can't have I, you shouldn't have the jth character. Allowed characters is this with an I in it. If the length of allowed characters is equal to 0, then next char is equal to the next char. This should be set to I. Self last use char, letters used so far is add next char. Elif, if they're both none, answer word at I is none, and answer word at j is also none. Then that's really tough. Because I have no information about what one should be, what one shouldn't be, like that. Does that case exist? Is there a way that they're both not none? They're both none? Probably. I mean, it's got pretty insane pretty quickly, huh? Elif answer word I is none, answer word at j is none. Else, Elif, if they're the equal, so we know that they're both not none. They're both not none at this point because we've checked every other case. They're both not none. If they're equal to each other when they shouldn't be, then we got a problem. If answer word at I is none and answer word at j is also none. If answer word at I is none and answer.
You didn't go?
I'll go, don't worry.
Okay. So you have a car if you need.
Yeah, I know, I'll go.
The car has a petrol, hopefully.
Yeah, yeah.
Okay, I'll get dressed and go. Yeah.
Yep. $4.39, $3.30. Answer word I is none and answer word j is none. What do I do? I don't know what they shouldn't be. Answer word at I is none, answer word at j is also none. I know what they can't have individually, and therefore I know what they could be. I don't know, I don't even know what to do. Like, if it's somehow I get to a position where, like, I knew that you and you match, and I know you're a B, and I know you're like, I know you and you match, but then I don't know if you should be like a B or a C. I don't know if you should. Maybe I don't know if you're Like it says 0, but I don't know if it should be a B or a C. And then this one says, like, comparing these two, it says 0. And I mean, at some point I'll be able to figure out if you should match, but maybe before then. Let's just maybe if I can get a test case, we'll see. All right, I just want to see like if I get that none case, you know. Oh, what? I didn't get a print statement. Oh, I must have. Let me just see why. Print. Exceeded allowed characters. LPS value, whatever, doesn't. What is it? LP. Oh, LCP. I think I put a print statement out before every quote. Can't have L and R. Well. Damn, I actually backed. Well, that's just because in the wrong order, like. What's the L and R value? So. L 1 2 3 4 in 5 6. So you can't have an A. This one also can't have an A. Answer word. Just see if this helps make it a bit wider, the window. Zero, 1, 2, 3, 4. Yeah, okay, so this is the issue. Apparently, see, I did say adding none might be a bit weird. And answer word at L is not none. And I also think that I should have done this like in here. Answer word L. If answer word is R is none and answer word L is not none, then answer word L is, if answer word L is in the can't have of R, then that's a problem. And the flip also exists. Wait, does this say the same thing twice? No. Oh, it's also none, yeah. If R is an L, otherwise happily assign it. Answer word R is not equal to... God, this is getting so weird. Oh! Well, we tried. Yeah, I got no proof. That's what it is. Like, I just have no way of actually guaranteeing anything. So I'm just guessing and hoping like it doesn't actually work. Alright, well, I'll probably read submission tomorrow. I like to not read it like on the same day just because I'm sad, but I'll read it tomorrow and figure out how to do it. But oh, I feel like I'm close. I just don't know. I don't know what else to do. There's some missing logic in the actual construction of the word, like when to take a new character. Like I must have filled this one in late. Like after I filled in a C, for example. A, B, C, D, E, F, G, H, A, B, E, F. Like that should be a G and that should be an H. But I got a C and then a G and an H, you know? Like, Oh, that's true actually. Because I'm not doing it in order anymore. Yeah. Okay. So by sacrificing doing things in order for like trying to do things correctly, I don't necessarily like I apply a C, I might apply a C here first and then put a B and then instead I have to put a D here, you know? Like I see why it's going wrong. I think at a high level I understand what's sort of going wrong, but so maybe it is better to sort of prioritize like these numbers first. Maybe I'm supposed to go down like this. Get all the information I can about a particular column. Get all the information I can about a particular column. About a particular J value. Everything I can before I move on. That way I can pick like the smallest or something. I kind of like that idea. So instead of going like row by row, you actually go column by column. So for J in range 1 up to the end, for I in range, I guess 0 up to the J value, but not including. For J in range 0, what do I want? 1 up to the end. For I in range 0 up to but not including J, and then like apply your logic. That way you're kind of applying the rules by prioritizing. When you apply your rules, you're prioritizing like doing these guys first, making sure that they get the smaller letters maybe, and then afterwards go down, something good might happen. would actually work. Oh, I'm tempted, but I think that this is the last sort of hole in my plan. Is like I don't know how to handle that case. Oh, I forgot about that. I've been the acceptance rate at this point. I don't know. I'm single-handedly bringing it down. I just want to see what cases I'm failing still, so I can fix it. Is it? Oh no. TLE. Okay. Well, that's a bit more encouraging, but I do think that what the heck happened? I've never had that before. Oh, thank you. Yeah, cheers. I wish I had passed this one. That would make it taste a bit better. So, what? Oh, wait. I just realized something. N is 100 or 1,000, but the matrix is 1,000,000. That's why, because it's like I'm doing. Oh, and I said I think I can naively do the window thing because it's N. N is only 1,000, but actually N is bigger than 1,000. N is 1,000,000. Like the number of elements is 1,000,000. So I'm doing like I think am I doing like 1,000,000 squared? Is that what's happening? What am I doing? Because it is. I noticed from the start it's quite slow, but I kind of just ignored it because I had logic issues. But if LCPij is greater than 0, prefix len is equal to LCPij. Like I understand. I knew that there was redundancy because I was like redoing the same comparisons over and over again. But then again, I also thought that I guess for example, like if you have a largish number, like a 5 or something, there's a 5 somewhere? I shouldn't have drawn over this so hard. Oh, that's a symmetric value. 274. Then does that mean if I go down the diagonal, the next value will be at least 273? Like in the sense that oh, yeah, wait, is that a fair condition? Like if I inspect, if I have a particular non-zero value, wait. If I have a non-zero value, and then I look diagonally down to the right, I'd expect the value to decrease by 1, right? Because, like, hang on. I can't believe I didn't realize this earlier. Hang on. If you have A, B, then obviously, like, 0, 2 should, like, the matrix at 0, 2 should equal 2, right? I forget what the matrix is called. But that means that P of 1 row across 1 row down should equal 1. It should be 1 less because it's like, if this thing matches exactly, then if I kind of cut off the first thing in the window, then whatever's left over, which is at 1 and 3, should be also matching still. wonder if that works. If this is greater than 0, if R at, sorry, if the matrix, what's it called, LCP, if the row we're at is greater than 0 and the column we're at is also greater than 1, I think. Well, if your row is greater than 1, if your row is greater than 0, then that should be true anyway. If the row is greater than 0, then check the, okay, so diagonal previous value is, diagonal previous value is the LCP at the previous row and at the previous column. If diag previous val is not the same as prefix is not the same as the current val plus 1, I think we can kind of shortcut the contradiction finding. I think all this stuff with sets and stuff can actually be summarized by this rule. Like, whatever's below and to the right should be 1 less than, and if it's not, then that indicates that something went wrong, like there's some logical issue with the matrix. And otherwise, if that doesn't happen, if this does work out, else can I continue? Because like, no, this isn't right. Wait, what am I trying to say? I'm going the wrong way. I have to go down. I can't go up. Like, if I see a non, that doesn't mean that up here will be a non-zero. It means that beneath it should be a non-zero. So if it equals that, wait, what am I trying to say? If the diagonal previous value is equal to that plus 1, then like we're already pretty confident we won't see any contradictions, right? So then continue. Yeah, is that right? If I is greater than 0, diag previous value is equal to LCP. Yeah, we look at the previous. If it's one more, then we're like, okay, the scans that we did in that previous point is going to be the same scanning we did in this point, with all the same updates and everything. So there's no point doing this while loop. Prefix length is greater than 0. Otherwise, we're seeing something different. Else if the diag previous value is strictly greater than this value, then this is illogical, right? Because the diag previous value is saying, look, there was all this stuff that matched before. So chopping off one character from each of the windows should still, yeah, I think that's right. And then else, then if it's less than, that means that we don't know. Like we can't be confident as to what just happened. No? Okay. I thought maybe this would be enough shortcutting to Nah, but surely not. Whoops, I didn't mean to click that. Is it just a bunch of A's? That's funny. I don't... Wait, let's just clarify. If I was to get rid of that shortcut, does it actually TLE in the terminal? Because like redoing all the window checking over and over again. It does. Can I trudge my way through again? Oh. Oh, I'm actually really close. And yet it's quite an innocent looking test case. What happened there? 311121111. Okay, this one I will draw out. 311 121 111. It is symmetric, and yeah, it's all good. So then I have 3 characters. Whoops. I have 3 characters, and then if I have an A here, so I'm going like this, right? So this matches, like we have the A here, but we know that this shouldn't be an A. Because if it was an A, then this would have said 2 to be like AA versus AA. But I wrote an A, didn't I? I thought we dealt with this already. Maybe my changes have caused it to undo itself. I want to see what the can't haves are. Like at set 012, it should have an A in it. But it's empty. Of course it's empty. And the reason for that is because when do I add to a can't have? Like, this is when I wanted it to. This shouldn't say, it said +1 again. So I never ran. God damn it. I didn't need to fail that. I knew to, it's just, I hate myself. Oh my god. So wait, so this case never had to run, the thing I passed. This was actually okay. There must, if someone could prove this, I'd be so sick. And by someone, I mean me, obviously. I don't know who else would do this. Oh, how many failures? Honestly, not my worst. 12.5% acceptance rate, not my worst. I've had 11. I've had 11 failures. So, you know what? I'll take it. Normally I don't submit until I can see the proof. But it just felt like there was too much stuff happening for me to just do it like how I like to do it. I printed everything as well. I could have easily gotten another output error. Oh, but it was only once. It was fine. I wonder what you could do to save space, because I use so many sets and things, but I just feel like that information is really important to carry across. Every line has a purpose, but also I did copy and paste, and also I don't know what I just did. The thing is, even though, okay, I passed all the test cases, fine. Even then, I'm still not 100. I'm sure like you could generate a test case that could make this thing fail. Because I have zero confidence in anything that was written. The individual bits I respect, but I just feel like there's stuff I'm missing. Like the individual ideas, I can't believe I had to copy and paste. I could probably make this into a function, but I can't be bothered right now. I'm annoyed that I didn't see this before. Because I think I could have seen that a bit earlier. I just, honestly, it's because I wasn't even thinking about time complexity. I was like, normally I do, but I was so like, what it was even happening right now. Oh man, alright, let's see what the better stuff is. To be fair, no one's running it in particularly fast time. Although this is much cleaner looking. Oh my god. N equals the length, yes. You make a word which is the empty string. Okay, so instead of using none, they use the empty string. That's fair enough. Current is the order at A. Construct the string starting from A to Z sequentially. Construct the string starting from A to Z sequentially. What? For I in range n, if not word I, so if we haven't put anything there, if the current is greater than that, then return the empty string. What? Otherwise, word at I is equal to current. For j in range I plus 1 to n, if LCP ij, then word at j is equal to word at I. Oh. Right. Yes. If the word at ij, like looking at a particular character, knowing that the current is A, knowing that the current is A, look through the entire LCP. If there is not through the entire thing, but through the all the columns that we care about, all the relevant columns. If the value is great at least 1, then we know that they should match. So we just make them equal. Current plus equals 1. And that tells you that you should only, because, does this actually work? And then once you construct a string that follows some of the rules, you check all the rules afterwards. Verify that it makes. For I in range, so for all the rows, and then for all the columns going backwards. If word of I is not the same as word of j, but there is a value there, then return this. Okay. Else, if I is equal to n minus 1, or j is equal to n minus 1, so if you're like on the end of the string, and LCP at ij is not 1, else LCP at ij is not equal to LCP at ij. If LCP at ij is not equal to LCP at ij, yeah. So this was the going down thing. Like you would expect this guy. So if they are the same character, yeah. If you've this is checking. This thing is checking. If you have a non-zero value, then look down and to the right, and you should see 1 less. Basically, that's what that's saying. If I is equal to n, I don't really understand this part. So under the condition that they're the same character, if I is equal to n, if we're on the end, oh yeah, no, that makes sense. Yeah, if I is equal to n minus 1, j is equal to n. So if you got the same character and then one of them's on the end, then you should see LCP ij is equal to 1. And if it's not, then and that's it. And I'm assuming you just separate that case because of index issues. Like if you try to cover that case here, yeah, because you wouldn't be able to look down into the right because it would index error. Well, there you go. There you go. Not a set in sight. This is the mode. Yeah. So this is what you're meant to do. Nice and clean. Pretty much identical. Yeah. Not insane looking. Fair enough. You know, people may be a little slower, but probably somewhat logical, you know? And then you got me. Oh my god. I do like this though. The final solution is quite nice. Construct a string based on the rules that you see locally and then check all the rules that you can. God, 12.5%. Well, at least the streak continues. Anyway, good stuff. How long is the video?